The following program was provided by an independent producer solely responsible for its content. The opinions expressed do not necessarily represent the views of this station, its staff, board of directors, or underwriters.
Welcome to Gate City Chronicles. I'm Kevin Avard, your host. Today we have a special program dealing with education and robotics. And today I have Jacob St. Germain and Dan LaRochelle.
Yes.
Hey, we got it right. If I write it down, I'll get it. So welcome to the show.
Thanks.
So as I walked in, I saw a whole bunch of robotics as I'm looking at it, and I'm thinking, oh, I used to play with these things when I was a kid. And these aren't just necessarily kid Tonka toys anymore, or whatever they're Lego sets or whatever they were called. This is a serious program that we're going to be discussing that is part of higher education. Is that correct?
Yeah.
Yes.
Dan, you're a professor.
Yes.
At the Manchester Community College.
Correct.
Right.
And I do robotics and advanced manufacturing, and we actually use this same system at the school to teach robotics design. So this can go all the way down. The metal system can go all the way down from middle school all the way up to college.
And Jacob, you've been involved with this for some degree.
Yep, since sophomore year of high school.
You're a champion at this?
Yes. Recently won the VEX which is the college division of the robotics world championship, so that was really cool.
And you're down at WPI in Worcester?
Yes, I'm a freshman.
Freshman there,
Yeah.
Congratulations.
Thank you. Yeah.
And obviously you guys want to talk a little bit about this. So how did this all begin, and what is the purpose of it, this whole program?
I was Jake's mentor at Trinity High School. And, me and Joe Pouillat from Trinity, we've been really trying to grow robotics throughout the state with some great partners like Dave Kelly at Pembroke, and really bring robotics into the classroom. The best part about the VEX system is it's basically the old erector set with a brain and all the sensors and all the cool stuff. To build a robot, you need a hacksaw and a file. There's no elaborate machining, there's no welding. The kids can really explore their creativity, and there are open-ended problems through the VEX system. And that's where Jake comes in, is every year the game changes and he's got a new problem to solve.
So it's solving problems,
Yes.
and in the process of solving a problem, you're building a robotic to solve this problem.
Playing a game, basically.
What was your first?
I started basically my sophomore year. My freshman year, I actually was the journalist for the robotics team at our school, and I got hooked. It was awesome. It was crazy. So
I can do that.
Yeah, it was really cool. And that was always something I always played with Legos as a kid. And so this just seemed like the logical next step. So started, playing around with it. It was really cool. And then I took a class in high school, and it was just
In
history
high
from there.
school, at Trinity High.
Trinity High School.
And what was the class?
They called it ACS, which was Advanced Competitive Science. So basically, we built a robot, like a little tiny robot, to play a game that my mentor, Joe Pouillat, would teach us.
So off camera, we're talking a little bit about competency-based outcome or something to that effect.
Yep.
And that's the model here. Could you describe or tell what is this competency-based?
Sure. Basically, what we're trying to do is get kids to think outside the box. Okay. Get them out of their comfort zone. There is no answer to these problems. They come up and essentially there's a whole bunch of competencies that they can actually demonstrate through their creations.
Such as?
Whether it's programming a simple program, building a mechanical gearbox, wiring up a motor, wiring up a speed control, programming a PID loop or an algorithm, all very fundamental stuff that Jake learned in his ACS class.
Yeah.
But then you take the fundamentals and you give them a solid foundation, and then you use robotics competitions to really encourage that outside of the box thinking. Well, I know this, this, and this. Well, how can I put these together to make this? And that's the beauty of this. It really combines mechanical, electrical, and programming all into one, and it puts it into their hands. These guys work amazing hours.
Now it's not school at this point.
No.
This is fun.
This
out
is
of
all
school.
outside of
Yeah.
school. And these kids, they take the robot home. They work, in New Hampshire, we have a great bunch of event partners throughout the state at the high school level. And we try and have them compete every couple weeks starting in October. So at the end of October, the first one's usually at Trinity. Okay, and then we have another one in Kennett High School, another one at Pembroke, another one at Pinkerton, another one at Winnicott.
You compete against the public schools at all?
Yep.
Yeah, all the schools compete in the state.
Were some of those public schools that you mentioned?
Oh, yeah.
Okay.
Yeah. Yeah, a lot of.
They all sounded like they were.
Yeah, no.
No, those are the hosts of the competitions.
Yeah.
But what we're doing as mentors is really trying to give them the opportunity to be creative. So their robots that they build November 1st or end of October morph competition to competition. They actually get to test their design concept and really prove out that engineering design cycle, and they get to practice that iteration cycle that all the engineers talk about, the value of you build it, you design it, you get the sweaty palms, you test it, you're like, oh, well, I kind of like what he did, and I kind of like what he did, and then you make your own. And every competition, as Jake will tell you, it gets better.
Yeah.
Now, Jake's with VEX U. VEX U is brand new. Why don't you tell them a little bit more about VEX U?
Yep. So VEX U is basically the college version of VEX. You basically use the same system, same components, but you can also do a little bit more like 3D print things. There's a lot of other things you can do which are really cool. But really with this, with the high school robot, you built one robot and you competed with other people and you formed alliances and competed that way. But with VEX U, you make your own partner. So you have two robots that you build. They have different size constraints, 24 inches and 15 inches. And essentially, you build another robot to play with, and you compete through the entire tournament with that.
Now, are these the Destructo robots where they go into the ring and the tournament?
No.
Or do they try to actually accomplish something other than...
Yeah. So each year you get a game. This year, our game was basically you pick up these cubes and put them on posts around the side of the field. They were color cubes, so the blue team, if you're on the blue team, you picked up the blue ones and scored them. Also, there was kind of a twist. You were able to build your own goal, and that was worth double the points, essentially. So each piece you built of the goal was worth 4 points or something like that. So
working on these projects, that helped you get accepted into WPI?
So yeah, I never wanted to be an engineer before I did robotics. I never even thought about it.
You were a journalist.
Yeah, I was going to be a journalist.
His sister was on the team.
Yeah.
That's how he came.
Yeah.
Oh, cool.
Yeah, so I never thought about it before. And then I started doing this, and I was like, wow, I could really see myself, doing this for the rest of, the rest of my life.
It's not work.
Yeah, it's not work. It's fun. It's also very challenging, but,
Sure.
But I started doing that, and then I applied to WPI because they have one of the best robotics programs in the world. So I decided, hey, that's really cool. And they also have a VEX scholarship that you can apply for, given to people, and I got that too. So it was definitely very, very helpful and influential.
I don't know where I saw it. Maybe it was YouTube or Facebook or something like that, where they were showing some robots that were made at one of the universities, and they were in the shape of dogs.
Yep.
And they were.
That was WPI, yeah.
Was it? And they were running, and
Yep.
I'm thinking, wow. And then somebody would go walk by it, and they would kick it, and it would correct itself. And I'm thinking, that's kind of scary, man. This is like Matrix stuff.
Yeah.
Really
cool.
Or Matrix or something.
Yeah.
Just, wow, it's come a long way, baby.
Yeah.
I mean, these things can actually probably help out with fire rescues or bomb squads or something.
Some of the robots they were using at WPI were specifically to help with the Ebola, stuff like that. So it's definitely very real world type things.
It's a cool thing. Now, in the process of learning this, you're learning your math skills, you're learning how to problem solve, you're learning computer, all kinds of things with this program. So you mentioned a key word that caught my ear was algorithms. Somebody said that they're not necessarily being taught like they used to be years back. Is that a problem that we're having right now in our education system?
Jake has probably a better answer for that one because his robot, like the college level robotics, really went into a lot of that stuff.
Yeah, we used a lot of, so our program, basically the autonomous period which is where no one controls the robot, but the robot, it's all programmed. We used a ton of different algorithms and things like that to really get the robot to work consistently well on every field or whatever. We used a lot of different sensors, gyros, encoders, things like that. Things like that. The programmer on my team he goes to WPI, and he was going into crazy, different algorithms and stuff. So I guess it depends. For some people like me, it doesn't come as easy. Things like that. I haven't really been taught as much, but
he's been introduced to it.
Yeah, I've been introduced to it.
And now he knows more about programming and why motors behave the way they do. At the high school level, the matches are played 2-on-2, and it's 15 seconds of autonomous followed by 1:45 of operator control. Okay? At the college level, it's 45 seconds of autonomous. Autonomous is the robot's basically doing what you tell it with its brain, and that's it.
Are we creating artificial intelligence?
Pretty much.
Yeah.
The robot we had was able to recorrect based on actions that it did before. So say it missed a cube or something, we'd say, all right, don't do this, do this. So essentially it made decisions for itself based on the outcome of whatever happened.
And let me be very clear. What they did with their robots at the World Championship has never been done before.
And what did you do?
Well, you'll see the video a little bit later, but it's almost like a symphony of robotics, okay? A lot of robotics at the high school level, when they start, the robot only has 15 seconds, it drives out, it does a task, or maybe two, and that's it. Their team's programming both robots at the same time. One's scoring while the other one's gathering, and one's building the skyrise as the other one's scoring.
Yeah, they work together.
It was absolutely amazing.
Yeah.
It impressed everybody at the competition. This is the first time the U.S. has ever won the VEX World Championship on the VEX U division.
Well, congratulations.
Cool, yes.
So
awesome. Are we going to be trying to promote this more and more through the colleges, through Manchester Community College?
Jake actually inspired me a little bit. We've been trying to grow this for a little while, and I have some colleagues at NHTI and UNH, former students and former teachers that are interested in doing VEX U. I recently received an innovation grant through the community college system, and that is to start VEX U in New Hampshire for the very first time and really try and get all the community colleges and all the universities to compete at this college level to really let the college kids really showcase their skill set, mechanical, electrical, and programming, and compete against one another in a very friendly atmosphere, in a very sharing, and really trying to grow our education system.
Fantastic, and of course that'll help with manufacturing up the road.
Well, that's again, I tricked Jake. We tricked Jake into doing engineering, and now he's one of the best robotics kids in the country. Okay.
It's nice to have on the resume.
No, but he went from a journalist to this in 4 years. That's not bad.
Yeah. Oh no,
that's awesome.
That is good. That's great.
Yeah.
And it's nice to hear stories like this. I can't wait till we see the video. But when we were kids, we saw these little erector sets. We can make a crane, or we can make something, and of course then you miss a piece, and it always ends up in the junk pile, whatever. But this is a great idea, and it's fun in education.
It really is.
So we're going to take a break, and we're going to get set up so you can do a little demonstration, and maybe we can see some of the videos.
Sure.
Thanks. Great.
Awesome.
We'll be right back. And we're back. So tell me what this is, Jacob.
So this is one of the robots. This is actually the high school robot. Basically, I came back during winter break to help out some of the kids at Trinity High School, some of my friends. So they essentially built a copy of one of my robots, or I helped them, inspired them, I guess you could say.
Right.
And basically the way this works is the robot has the same kind of arm linkage as what I use on my robot, or our robot. And it basically lifts the cubes by using these motors here. The gears, kind of cool. This allows them to be able to hold 2 cubes at a time, which is pretty cool. The way it works is basically the robot comes down on a cube, it locks, and then it's like a one-way kind of lock, and then it releases here.
And it uses pneumatics to close it and drop it.
So.
Pneumatics.
Yep. And then this also drives around, and it's pretty cool.
Yeah, I noticed you got the wheels on it.
Yep.
And it does.
Yep. So,
it looks pretty complicated.
Yeah.
Wow.
A lot of time in this one.
That's a lot of wires, a lot of gears, a lot
Yep.
of controls, and you get the funky things that you play video games with.
Yep.
Exactly.
Use the controllers. It's pretty cool.
How can you hate it? Right? Now you got another thing right over here.
Yes.
Gonna put that on here, or
Sure.
and this looks like one of those robots.
It's called Ike.
Ike?
Yeah.
So this is Ike, okay?
Yeah.
Um,
I like Ike.
Ike is just a very simple little robot, okay? And this is a brand new robotics design system called VEX IQ. This goes all the way down to second grade and all the way up to college.
Second grade.
Yeah. They actually, in second grade, you know, if you look at some of the standards, they talk about building simple machines and Rube Goldberg projects. Well, VEX actually has a bunch of free curriculum that brings that technology all the way down, just building and snapping together the mechanical motion systems.
Boys and girls like it equally.
Boys and girls love it. It's actually really good for girls because this system has a patented thing from a kid from WPI named Art Dutra. He patented something called the 3D pitch. So no matter what you build, it always snaps back to itself. So you can build whatever you want and then attach the brain later. It can have 12 motors or 12 sensors, and literally out of the box, it requires no programming. And this system is designed so that you can crawl, walk, run through your robotics experience all the way up to VEX-U.
You know, and what it does seem to do is it seems to put a product with something that you're learning and gives you a hands-on application and understanding as to why. You know, why do I got to learn this, this, and this? I'll never use it.
Sure.
Exactly.
Yeah, you can.
Well, again, it's always that open-based, that open-ended project learning, okay? This, and one of the things that we're doing at Trinity this summer is we're doing our, basically a STEM learning program. And we have 4 weeks. The first week is 3D printing. The second week is going to feature Ike. We're going to do animatronics. We're going to take apart little stuffed animals. We're going to build mechanicals inside, and we're just going to let the kids explore. You know, these programs really meant between grades 3 and 6 to really get their foundations set and prove to them, especially the girls, that they can do this.
Yeah, in
reinforce it.
Girls seems to have there seem to be not as confident.
Well, we see this especially on the Trinity team. In a lot of cases at the high school level, we have a girls-only team, and they break off and they build, because in a lot of cases, sometimes they'll get pushed out of the way by the boys because the boys just want to build. They're crazy. The girls are very methodical.
They use both sides of their brain.
They attack the problem very differently. And we encourage that. And they go through the same engineering design process as everybody else. Their robots evolve just like everybody else. In fact, we have Melissa. She's at Wentworth, and she is a mechanical engineer, and she's doing great.
So how can people get in touch with you or learn more about this?
You can go to the Trinity Robotics site, trinityrobotics.org. That's our team site. You can go to the VEX site, vexrobotics.com, or the Robotics Education and Competition Foundation's website.
Oh, great.
Those links will be there.
Thank you for sharing this with us, and I believe we're going to be seeing a video or something to that effect very shortly. So,
yes.
This is great news, and congratulations again. Thanks for coming on the show.
Yes.
Great.
All right.
Thank you.
So we got a little video to show you, and then thanks for watching Gate City Chronicles. And if you want to get your children involved with the robotics, check it out. This is a great idea. That looks like fun. Until next week. Okay.
42.
Yeah, we got one. Okay.
All right. We're going to go to VEX U, the first match of the VEX U finals on the Northrop Grumman field. Let's get to that one.
But before we do that, let's take a look at some of the VEX U divisional awards. And now it's time for the VEX U finals. Like I said earlier, this is a rivalry right here. Two of the best robotics programs ever. These kids all started in VRC high school, won world championships at that level, in skills, in the main challenge, and now they've moved on to the next level, and they're taking VEX U to the next level. So, I'm going to throw it to our VEX U announcer, Mr. George Chen. George, take it away on the Northrop Grumman field.
Thank you, Karthik. Welcome to the VEX U division and the VEX U finals here on the Northrop Grumman field. There are a few differences you might notice with our robots, and that is first, each team builds their ideal partner. Teams build two robots, one a 24-inch cube maximum size, and the second a 15-inch cube. Our autonomous programs are 45 seconds long, with the driver control period being only 75 seconds long. And now, let's meet the teams, starting out with your Red Alliance. Coming all the way from Auckland, New Zealand, they are the Auckland University Robotics Association, Aura! And over on the Blue Alliance, from Worcester, Massachusetts, it's Consigment Community College, QCC2! Our head referee, Rick, getting thumbs up around the field. Let's get this started in 3, 2, 1, go! And we start off with our 45 seconds of autonomous. Both of these teams have shown to be incredible competitors, scoring high in the autonomous period. We see Aura stacking it up, getting those skyrise sections in place. 1, 2, 3, 4, like it's nothing. Over on the Blue Alliance side, you see the same thing happening by QCC2. Here comes a drop of 3 from Aura. Wow, incredible action. And remember, folks, this is all autonomous. The Blue Alliance stacking it up still. Both of them are going to max out their score on the skyrise solely in these 45 seconds. Up high go another set of 3. Let's see if they can drop it down. Wow, 7 cubes on red, 7 on blue. And the Red Alliance will take the autonomous bonus. Drivers, 3, 2, 1, go! Incredible activity already, but now it's time for human control. Aura with their 2 robots, Big Mac and McChicken, fighting it out in the corner. QCC2 blocking it out, trying to play defense against the scoring machine that is the Big Mac. Over on the Blue Alliance side, QCC2 and the Blue Rooster heading over to the tall goals, looking to drop them down, and they're trying to outcompete that Red Alliance team. 45 seconds left on the clock. And looks like red and blue are neck in neck. Blue Alliance looks like they lost us a cube there, and the Red Alliance claims ownership over one of those blue goals. As we come to the last 30 seconds, McChicken picks up a red cube, goes up to claim that goal for the Red Alliance. One last cube gets added on top for Big Mac on the skyrise of the Red Alliance. And we're down to 15 seconds now. All 4 robots on this Red Alliance corner. Blue Alliance scoring, Red Alliance coming behind. Down to 5 seconds now, folks. Blue Alliance going to top off their skyrise. 3, 2, 1, and that's that. I thought that was pretty incredible. Paul, what do you think?
I am not standing in the right spot, but I will be in a second. All right, everyone listen. Those skyrise sections were built entirely in autonomous, and the Red Alliance won by 1 floor goal. A cube in their Alliance home zone was the difference. How would you like to build a 7-high skyrise section in Auton and lose autonomous? But QCC came back during teleop and they played awesome during the teleop period. Looks like outscored Cube autonomous with 7 skyrise sections. Amazing. Both alliances, amazing robots. The days of high school students having a prayer against the college teams are over.
That was incredible. I want to see the autonomous replay. I don't know what our replay is, but let's take a look at it because that was amazing.
Yep, it's the autonomous replay. Remember, everyone, these are all in autonomous. Robots working together to build the skyrise section with cubes during autonomous. These are not driver-controlled robots. 7 skyrise sections for blue. 7 skyrise sections for red. 7 cubes on the skyrise tower for red and for blue. At the last second, boom, boom. What an autonomous match. So, Jason, we have the scores.
No one driving. Let's see the score. Wow, 92 to 86. QCC almost came back in that one. I cannot wait to see the next match. That's 1-0. It's not over yet. They're going to have a second match in a bit.
So back before we go to the...
All right, now it's time to play VEX U Finals, match number 2. Aura, the Red Alliance, won the first match. If they win this next match, I think they'll celebrate a little bit more than the middle school winners did. Just saying. All right, George, take it away.
Thank you, Karthik. Once again, here in the Red Alliance, they won the Excellence Programming and Robot Skills Award for this championship. They're looking for a clean sweep. Please welcome Aura from Auckland, New Zealand. Facing off against them, they're used to being the underdogs. In our eliminations, they knocked out last year's divisional finalists. They also knocked out their partner team. They're looking to knock out Aura in 2 matches. Please welcome QCC2 from Worcester, Massachusetts. Here on the Northrop Grumman Field, we are ready to go. Let's play the second match in 3, 2, 1, go! And we're starting off once again with the 45 seconds of autonomous. These human players working perfectly with their robot counterparts to create those sky rises. We saw in that last match they played, both teams managed to tie it up on those sky rises. It was down to those floor goals that made the difference. Let's see what happens this time. Were there any lessons learned? We start out with 4 cubes apiece on those sky rise towers. And we're going for 7 sections on both sides. Blue Alliance going up for their 7th section. Oh, the Red Alliance is empty-handed this time. That'll give the Blue Alliance a chance to redeem themselves and tie up the match. The Blue Alliance takes the autonomous bonus. Drivers, 3, 2, 1, go! All right, now it's the Red Alliance that has to play catch-up. Up high goes 3 cubes and straight down onto the skyrise section. The Blue Alliance and Blue Rooster dropping those 3 blue cubes down onto the medium post. And Big Mac from Aura is out to get as many cubes as he can, going for that number 8 cube on the top of the skyrise. No, they've changed their mind. They're going to go block out QCC. Oh, there's a push and shove and match. These huge robots going head to head, and it's the Blue Alliance that takes it down. We're at 35 seconds left, and Big Mac looks like it's a little bit shaken from that confrontation. Their smaller robot, Met Chicken, going to play ownership games over on the far end of the field. 25 seconds left on the clock, and the Blue Rooster is picking up the Red Alliance cubes. They're letting their other robot clean the field of Blue Alliance. All Blue Alliance cubes are almost scored except for that last one. With 10 seconds left on the clock, all Blue Alliance cubes are on a goal. The Red Alliance looking to clear up, trying to de-score 1 goal with 3 seconds left on the clock. 2, 1, and that's the match! Unbelievable plays by both sides. Paul, tell me what you think.
Okay, so in this match, the Blue Alliance won autonomous. I just want to state, in that first match, the difference was an extraneous cube that just got clipped the wrong way by a robot that rolled in to the Aura scoring zone. This match, that didn't happen, and Aura was empty-handed. But I say the play of the day, if you're going to clear all of your own cubes, what do? The Blue Alliance, QCC, goes ahead and takes 3 of the red cubes to tail that scoring opportunity away from them. A brilliant maneuver, also with another great maneuver that I'm hoping we see on the replay, is that complete battle for the goal in the middle there, where QCC out-pushed, out-punched, whatever you want to call it, to get their 3 cubes near the Aura scoring tower. Just a complete flawless execution by QCC that match.
There were a lot of plays. It could be great replays in that one. Let's see what we've got. Let's see the replay.
And there it is, the battle. The battle for the tower. Just pushing, bouncing, weaving, and the drop. Crowd goes wild, so let's see the score. Are we going to a third match?
They did it. 103-74. They will be going to a third match.
Jason, it looks like we are indeed ready to restart finals match number 3. Jumping the gun a little bit in that last try. I'm getting thumbs up from our referees, so let's give this one more shot. Finals 3 in 3, 2, 1, go! And with the 45 seconds, we start off with the Skyrise building. Once again, red and blue racing each other. They're neck in neck. And as always, they've already pre-scored one at the very base of their Skyrises. So it looks like Aura's pulling ahead just by a little bit. Both of them lifting their arms up with the 3 stack. The Blue Alliance is first to get down. The Red Alliance comes in right behind them. And we're going to finish off the stack. There's still 15 seconds left in the autonomous period. Aura managing to get their 3 this time. Looks like the same thing happened to QCC2 as they raise their arms up high. Can they get it on? Oh! 2 go off for Aura. And that'll give the Blue Alliance the autonomous bonus as we move to driver control in 3, 2, 1, go! Oh, an incredible minor error that would normally be easy for any alliance to get over. Here in the finals, man, it's going to be tough for Aura to catch up with those 10 minutes, 10 points given to the Blue Alliance and that powerful scoring machine, the Blue Rooster from QCC2. Oh, Aura's choking there. They pull the cube a little bit too far up. They're going to have to knock that cube over. No, they decide they're going to go for some pure points now. Down 3. Blue Alliance owning 1, 2, 3, 4 of the goals now. And you can see this game is purely offense right now. Both alliances focusing on getting as many cubes up as possible. And Big Mac now being guarded by QCC2. 3 go down for the Blue Alliance. The Blue Alliance holding back the Red Alliance. As Mech Chicken tries to keep QCC in the corner. Big Mac is being held in the corner by the Blue Rooster. Up high goes one more cube for the Blue Alliance with 5 seconds left on the match. It's anyone's game. 3, 2, 1, and time! Absolutely incredible way to finish off the VEX U division. Paul, tell me about what you saw.
What I just saw, I think, was the first U.S. team to win the VEX U division. That's what I just saw. And it all came down to flawless execution in autonomous mode. Both teams are amazing. Aura has been the team to beat all year in VEX U. They dominated during the division play. They were excellent on the field today. Just some small minor errors and some flawless execution by QCC is really what made the difference. QCC had to play their best to beat the best, and they did it. And they probably will be the next VEX U World Champions, but we still have to count the score. We need the tallies. Let's see some replay. The overhead shot the triple, both alliances making their huge skyrise sections. Remember, this is autonomous, and here's the difference maker. Aura gets stuck up on the top, drops 2 of their cubes. Their third cube gets stuck on the top. That right there was the difference in the match. So, let's see the scores. Your new VEX U World Champions, QCC2 from Worcester, Massachusetts, United States. Karthik, back to you.
Thank you for watching Gate City Chronicles, and we want to thank our sponsor, Avard Cleaning. They've been a sponsor for quite a few years now, and we appreciate them being a sponsor. And if you want to be a guest on our show, contact accessnashua@gmail.com. We'd love to hear your story. Until next week, thanks for watching.
The preceding program was provided by an independent producer solely responsible for its content. The opinions expressed do not necessarily represent the views of this station, its staff, board of directors, or underwriters.